就是你哦，好玩吗？你讲，呃，路上
你看我刚刚这样子是对的，
不对啊，
哪位置啊？
啊啊，
这样子，我觉得那个没有线的啊，
没有车不要紧啊，不管它了啊，
最大的
能力。
技术。
你说 you okay 啊？You're sick 啊？也是？You're sick 啊？Today? You're okay? 那 OK 啊？OK. Okay. Do you have this paper with you? 其他应该是都是 online 啦，因为两个六曼没有指印，嗯。Okay. Let's see the first one. Define column. 哎呦，started 而已啊，开始了没？还没有，上课还没有啊？几时开始？哦，可以。Okay, let's see how to do this. Okay, let's see how to do the column things. First of all, you need to know about what is current is QT. So this one is coulomb. Coulomb, you know, is a unit for charge. Okay. So what is coulomb now? Coulomb will be IT. So one coulomb equal to what? Coulomb will be equal to the unit of current. Do you know the unit for current? What is the unit? Ampere. Do you know about the unit for time? Second. Okay. So it's ampere times second. Coulomb equal to ampere, product of ampere and the second. Okay. B, the flow of the charge. Electric current is a flow of the charge. The following list underline the possible charges for a charge carrier. Okay. So the charge must be equal to n times 1.6 times 10 to the power of minus 19 coulomb. It must be multiple of this. So can you see which one is a multiple of this? Is this number the multiple of this? How do we know it's a multiple? So you have to take this number, go and divide it by this number. If you get a whole number, that means it's a multiple. So is the first one a multiple? So this one will give you 5. Is 5 a multiple? Yes, because there's an n here. That means we can say that 8.0 minus 19 coulomb is also equal to 5 times 1.6 times 10 to the power of minus 19 coulomb. Okay, so you have to use this way to identify which one is a possible charge carrier. Do you understand? Multiple. Is this one also multiple of this? Is 4 multiple of 1.6? No. Is this one multiple of 1.6? This one, yes. Is this one multiple of 1.6? Yes, sir. Yeah, come in. That means this thing is the smallest one. Smallest. So is this one the smallest? This one smaller or this one is smaller? 20 is smaller. 20 is smaller. And this is the smallest. 这个最小. This is the smallest. Yeah. This one is simple. Oh, you are so clever. You not been here for quite some time. Where you been?
Last week I'm sick.
Then the week before the last
Before
week.
that, I go
So,
yeah, KL.
all Malaysia one go tour. Okay, go here. So nice. Okay. Okay, actually this one is not the answer. This one cannot. Do you know why cannot? Because you need to know, this one the concept means charge is quantized. The meaning of charge is quantized is it means E equal to 1.6 times 10 to the power minus 19. Coulomb is the smallest one. Okay, this thing is the smallest. So if this is the smallest, it cannot be any charge smaller than this. So this is just like you cannot divide the charge anymore. This is the smallest charge that we can get. Smallest block. Do you understand the meaning of block? One block, two block like that. This is the smallest block. So that means this thing, this one okay. Do you know why is it okay? Because this is the because we can write 8 as 5 times 1.6. That means this one is built by 5 blocks. Have you played Lego before? So let's say you play Lego, let's say you build a ship. So you need to know how many pieces of Lego you need to use. So this one, to build this one, you need to use 5 Lego block. Okay. So this one why cannot? Because this number, smallest is this number. Can we use this one to build this one? Cannot, because 4 is not the multiple. What is a multiple of 1.6? 3.2, 4.8. What is the next number? Time 2, time 3, time 4 is what? 6.4. What is the next number? 8. That means all this one is multiple. Okay, multiple, 1 times. So this one cannot. This one can. Why this one can? How many blocks are there for this one? 1 block. So 1 block is okay. So it can be built by 1 block. Okay, this is okay. Do you understand why this one cannot? How many blocks that we use to build this? You have to use 10 to build this one. Can you tell me this number and this number, who is smaller now? This number is smaller or this number is smaller? This one is smaller. So this is 1/10 of the 1.6 line. So this one cannot use because the smallest block is this one. Smallest block. So you cannot use the smaller block. It cannot be smaller than this. So this one cannot. So only this and this is the answer. Multiple of the thing. Okay or not? Okay, next one. We need to, this is a diameter, various linearly with the distance, linear. So this is a linear line. Current pass through, current. At S, diameter is D. At T, diameter is 2T. So different size, one small, one big. Draw the variation of drift velocity with the position between this and this. Do you remember the formula for drift velocity? Current, what is the formula for current? Do you remember about last week? We got AB, NB, NBAQ. Should be NBAQ. NBAQ, NBAQ formula. So N stands for number of charge carrier per unit volume. This N value depends on type of wire. If they belong to the same type of wire, then it is constant. So can we say this is constant? Is it going to be constant? Why? There are only one piece of wire, right? So this is constant. Area and Q. Q is a charge. Charge of the electron, is it constant? Also constant. Charge of electron is always this number. This number will not change, so it's a constant. I, is it a constant? Is here to here only got one flow. Because this is series. If it's series means single path. What can we say about series? In series, what can we say about the current? Only current is constant. So we need to identify how many part is constant. Constant. So normally everything will be constant except two things. So can you see that constant, 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 except these two is not constant? So B is I divided by N AQA. So all the things which are constant, I and Q are constant. If I and Q are constant, that means this one only depend on A. And the A is pi over 4 d square. I have got explained to you before. So now you have to put the thing in, then it will become 1 over d square. So this how obey something called inverse square law. So now you have to know how to play with this inverse square law. Inverse square law, you have to pay attention to the V. So when the diameter is D, the drift velocity is Vs. That means starting time is Vs. So what will happen when the diameter double? If the diameter is double, what will happen to the velocity? Inverse square law, you need to 1 over square of the previous number. So what happened to the number? It will become 0.25 of the original drift velocity. So do you know where is the next point? Next point happened at this point, right? What is the drift velocity now? Is it this number? Because 0.25, right? This one is when D is 2D. When D is 2D, drift velocity become 1 over 4. So 2D happen at point Q, point T. So it's going to be like that. So now we need to check whether it's a straight line or curve. So which one is correct? Yeah. How to draw? Now, how are we going to draw this thing? Okay. Inverse square law. If you see something like this, it's going to be the graph will be like this. Okay. If there is a square, the graph will be even lower. So same type of graph. Okay, so the graph will be a curve. So it's going to be a curve. Okay or not? Curve. Just draw the curve. Okay. Any problem? Do you understand the whole thing? How the graph is drawn? So first you need to know this formula. So you have learned this formula before. So we need to establish a relationship between the tip velocity and the diameter. Okay, so before you go on, you must identify the constant for this equation. Once you identify the constant, take out all the constant. Okay. Then finally, you have to introduce this d square into the equation. So you know this one is inverse square law. So inverse square law is very simple. If the value double up, you just take the 2 divide by 2, 1 over the number, then square it. So give you the next value. There is a law of graph obey inverse square law in physics. Okay, you also have to apply this one. Okay now. Then 什么事？刘曼他要拿华语，他要去拿华语。他讲他去大学读华语。啊？他要去马来西亚教华语。有人拿。奇奇怪怪的他想法。他喜欢 last minute 做一个决定，吓死了那决定。有啊，我见不到他，我已经跟他讲到口水干了，他不听，已经很多天了。嗯，有人止音啊？啊？我不知道，突然间他生一个想法，可能是啊，指定影响到。OK，是吧？连锁反应啊。Okay, next one, the Coulomb thing, I think you know what to do. So it's the same lah. Definition of Coulomb just C equal to A times S, right in sentence. Okay. Ampere times second, that's all. Okay. Second one, actually this one will not come out with exam because this one is something called electric field. Electric field is now in A2. So you learn all this again in A2. So you can, for the time being, you can skip the question first. Do we think we need to skip? That's all. If I teach you, do you think you can understand? One. Never mind. Next time. Okay, we go to the potential difference and the power thing. Do you know how to use this one to show this or not? What is the definition for work done? Force times distance. What is the unit? Unit of work done. So it's a unit of force, the unit of distance. So force ma times s. Today I going to give a talk in this A level for year 11 student. Actually during the talk I also advise them, because do you know why we take 4 subjects for A level? The best way to take is physics and biomass. Why? Because if you have physics and biomass, you can go for medical science like medicine, pharmacist. If you don't want this one, you still have a chance to go for engineering because you have physics and mathematics. Okay, so this is a safer way because a lot of people, they might change their mind one. Now you say you want to study medicine. After a while, you find that maybe medicine not suitable for you. When you see the blood, then you get fainted. So it's better you stand by some. You need a backup plan. So the best way is you have all these 4. If you're very, very sure about going for engineering, then maybe you can take further maths. Then your combination will be you're not if you feel that you're not going to take bio, then you can take physics, chem, maths, further maths. Then you can go for computer science, IT. If let's say you are very sure you want to go for pharmacy or medicine, then you can drop physics. Okay, then you have bio, chem, maths, 3 enough already. Huh? You drop physics for bio, can then you go for the medical lah. Medic that's the thing. Oh, you have to see what vision, what you want to do. So anybody you tell not problem. Okay. Checking 3 subjects a bit risky. Yeah. Actually, most of the job are related to engineering one. You can see outside job opportunities we see job opportunity most of the time they are related to engineering. Easier to find a job. Okay, if you just want bio and chem then you have limited choices You can only work in a hospital, pharmacist. Other field maybe you cannot go. Limited. Okay. Actually, they need certain good students. They will want you to have physics one, because if you don't have physics then you will not know how to operate those sophisticated like MRI all those things medical imaging, resonance, all those things all those machine if you only know bio and chem then you don't know how to operate now. The button, all those things the menu also you don't know how to read there's so many physics things over there. This is the thing okay. Okay, this one the M is kg, M is meter per second square multiplied by meter. Can all you get the same answer for this? Yes or no? Yes. Define potential difference. Remember the definition for potential difference. PD equal to work done per unit what? Per unit charge. Work done per unit charge. B is work done over Q. Work done per unit charge. Find the base unit of resistance. How to find? What is the relationship for resistance? V is IR. R is potential difference over I. Okay, correct. So how to continue? It can be V can be work done per unit charge like I. Because B is work done per unit charge. Work done, the unit we know already. So the unit of R is unit of work done. This is the unit of work done over the Q is also equal to IT. IT. This one is a base unit. This one is also the base unit. So that means here it should be Q change to IT. IT times I. So it's W equal to I square T. So I square I is the current is A. T is the time. Okay. So can you simplify this? Okay. So we have kg m square A minus 2 S minus 3. Correct or not? 直音跟到吗？直音 OK 吧？Good， 这里来不到今天。OK， resistance and resistivity. How to do it? What is the name of this law? One end of a wire attached to the fixed point. Force is applied to cause extension X. Wire has a cross-sectional area of 4.1 times 10 to the power 87, made from the Young modulus. Assume the cross-sectional area is constant. Wire extend. State the name of the law. What is the name of this law? Force and extension. What law is it? Start with H. Hooke's law, correct. It's called the Hooke's law. Hooke's law. Find the stress. How to get the stress? What is stress? Do you remember what is Young modulus? Stress over strain. Stress is force per unit area. What is strain? Extension over original length. So the Young modulus is F over L A divided by E over L. At the end is FL over AE. So this one is the formula that we always apply for Young modulus. Okay. We come here again. Stress, force over area. It has extension of this. What is the force? Can we look for the force? 0.48. Can you find the corresponding force from 0.48? What is the number? Can you get the answer or not? Can you get this number or not? How many Newton? 36. Do you have the area? What does this say about the area? The area constant doesn't change. Can you get the answer for this? 3.6 divided by 4.1 to the power of -7. So it's going to be 8.8 times 10 to the power of, that's around 6 or 7. 36. Okay, so you are going to get 8.8 times 10 to the power 7. Is it correct? What is the unit for this? EA, Pascal, Pascal. Okay or not? What is the strain again? Extension over original length. Can you read the extension from the graph? Is this S extension? Yes. Extension is 0.48, okay? But do we know the original length? Anywhere that we can get the value of the original length? No. So you are right. You have to use Young modulus for this. So if you found that you're stuck, you cannot go on anymore, use the second formula. So strain is stress over Young modulus. What is the stress now? This number. Are we provided the Young modulus? Yes, 1.7. So how much is the Young strain now? 8.8 power 7 divided by 1.7 power 11. 5.2 times 10 to the power of -4. Any unit for the strain? No unit. Very good. Any problem? Any question? Can follow. Slowly. Because physics normally sometimes this concept link with another concept. So you need to see the keyword. Oh, you haven't learned yet? Oh, this one. Oh, you haven't learned yet. This one is called Young modulus. It's something that we use to compare the strength of the material. If the Young modulus is very high, means the thing is very hard and very difficult to change the shape. Something like that. So just to know, learn the formula. Okay, next one is about resistivity. Have you heard about the word resistivity before? What is the formula for resistivity? R equal to what? Yeah, you are right. Rho L over A. Determine the change in resistance when this thing change. How do you find the change? So rho is a constant, A is a constant. Okay. Rho is constant, A is a constant. Why? Because in the question, you already mentioned the area doesn't change, even though the wire extend. So changes in R is due to the changes in length. So how to count? Do you know the changes of length? We are given the extension change for this to this one. So this is the change in L. Okay, even though this is X, this is L. Because never mind, you don't have to go to too deep. That means changes in L is actually changes in S. So resistivity is this number. Delta L is this number minus this number. So 0.6 minus 0.48 minus 3 divided by the area. So what is the area? This number. 4.1 times 10 to the power -7. So what is the answer now? Hey, Tim, you studied in some way that got give you scholarship or not? how much?
8,000.
8,000. So after minus the scholarship, how much you need to pay?
Yeah. Still quite a lot. Because I take 4 subjects, so it's not.
More expensive. Overall, how much? Don't know. You know?
You want to know, I can get back to you.
Yeah, yeah. You send to me. I want to see. You also have. Like, how much? 3 subjects. 看一下 record， send 过来看一下，做一下 analysis， 看一下我们大概花多少钱。做情报员，是啊，看一下，因为我们看一下大概那个价钱是一样的，没有啦，大概知道它价钱了。Okay, so this is about 1.1, right? Is it 1.1? You get 1.1 times 10 to the power minus 4. Oh, okay, now this one. Remember the formula. The changes is due to one of this. You have to see which one is changing. Row A not changing, stick to the old value. Delta L changing, so just substitute the changes. The unit in meter. Final answer will be in ohm. If you don't change, then answer will be wrong because everything had to follow SI unit. If not SI, change to SI. Okay lah.
Yeah,
是啊，可能4颗3颗，你4颗哦，4颗，44啊，44K 啊，43
Once before,
something, 4 something 啊，they consider cheap 啊，is it？啊，38啊，3颗啊，38啊，late fee 啊，late fee。How much you pay? You don't care because not you are not the one paying, right? Your father's problem, not your problem.
say something.
20 to 30 ah. Must increase the fee. Austin must increase. Ask for pay raise. Correct ah?
Then 谁给学校啊？
6楼那个会有的，会有的。Okay, so now force greater than 45 apply to the wire. How you may check that the elastic limit of wire not exceeded? When you apply 45, this is 45. Within 45, straight line. So in this one, the graph look like this. Then start to bend like that. There is a point here. This is called limit of proportionality. And then there's one more point called elastic limit. So this point is the borderline. Before the point, if you stretch before the point, you follow the original path, go back. It's called elastic deformation. When you stretch after this point, then you go through something called plastic. So this is elastic. After the point, it's called plastic. What is the difference between elastic and plastic? If you stretch before the plastic, elastic, it can go back. If you stretch beyond the elastic limit, you cannot go back anymore. Then it will go back with certain deformation. So there's a permanent deformation. That means permanent deformation, plastic. Because elastic means when you stretch the thing, when you release, you go back to original length. But if it's more than that, when you stretch more than that, you cannot go back to original length. That means they'll be permanently longer than before. Just like plastic surgery. They also need to make a lot of plastic. They need to see your nose sharp or what. They want to make it sharper. Then you have to do a molding. So this thing, your nose, if it's plastic deformation, it will not go back to the original length again. You go back, then the surgery fail already. They need to do a new one. Right now. Okay. So how do we check? That means if you remove the force, if you can go back to original length, what does it mean? Yes. If you cannot go back, then it's plastic already. So remove the force. And check remove the force. Okay. And wire return to original length. Then this is called elastic deformation. It doesn't return, then it is no longer elastic. Okay or not? You understand? So it's just like that. Resistance. Do you know what is the definition for resistance? Is the ratio of what?
Potential difference.
Potential difference over current. Correct. Right in sentence. Resistance is potential difference, ratio of potential difference to current. Ratio. Okay. Can you calculate the current? In Pico, you know how to change or not? You try to change, is it? Wow, the OSPEC is also not very cheap. OSPEC also 30K, 30 over 1 year. Until what time? No, Sunday okay. Tomorrow. Okay. B is IR. I is B over R. B 0.6. R 4 giga. Do you know how much is giga? Okay. Giga is 9, right? Let us do a recap again. Micro -6. Milli -3. Deci or centi first. What is centi? C centi, centi -2. D deci -1. 10 meter. After that, kilo, 3. Mega, 6. Giga, 9. Tera, 12. Pico, oh, before pico, there's a nano. Nano, pico, yeah. Yeah, no. We need to know this one. So, this one is going to be 0.6 divided by 4 to the power of 9. 1.5 minus 10 ampere. How to change the pico? How to change? If you want to change to pico, you need to find a pico divided by the value of pico. How much is pico? Minus 12. So it'll be what? What is the number again? 2. 2. So it's 150 pico ampere. Okay, pico ampere. Okay or not? Okay, can check or not? This one, check and see. I want you to try to check the unit for potential difference, then later you check together the answer. Got the answer? 哎，找到吗？不确定，我看看。Okay. Okay, the joule SI unit cannot have joule inside one. Okay, the unit for potential difference is energy over the charge. And if you do not know about the energy, you can use this one. This one also can. So what is the unit of E? From here you should know if you use a mass, it's kg v square like that, correct or not? So it's going to be kg m square s minus 2 for energy. All these are base unit. Base unit have mass, we have length, we have time. Mass, length, time. So this one is and then Q is also equal to what? IT. So when you change unit of V is unit of E, which is this one, divided by unit for this, ampere times second, ampere second. So it's going to be kg m2 a minus 1 s minus 3. Okay now. You know how to see the unit? Take one of the formula. Let's say you don't want to use this one, you can also aiyo. That's why 怎样跟你讲怎么这样惨呢？知音 Newman drop, Newman change to Mandarin. 知音 say you want to try. 你就坚定是你罢了。Only very few are very determined. 知音来，什么东西你是不可以的？这么为什么呢？就是你编的，就是你差那，你知道吗？你就是差在这东西忘记换，你这东西忘记换，每次就是差一点，差一点。Okay. I try my best to help you. I will try my best.
It's still difficult to ask the school to raise your school to give you a higher pay raise.
High raise, yes. I jump ship already like that. Jump to Sunway. Yeah. Okay. Try your best. 10-1 lah. Wait, cannot. Okay, vote. You know what is vote or not? Definition voltage is the potential difference. What is the definition for potential difference? Cannot. Definition must go based on the most basic one. The original definition. Not the ratio lah. Work done. Work done per what? Your teacher didn't ask you to memorize this one, man. Work done per unit charge, work done per unit charge. We don't use this one for definition one, no. This is Ohm's law. Stick to this one only. Okay. So what is 1 volt now? Unit for work done is what? 1 joule. What is the unit for charge? Coulomb. Joule per coulomb, okay or not? Can you write joule per coulomb or not? Coulomb, how to spell or not? Coulomb. 1 volt is 1 joule per coulomb, okay or not? Can lah. Okay.
Both is the units of potential.
Huh?
Both is units.
You're right. What is the unit for voltage? Correct lah. Correct lah. But normally we don't use voltage in physics. We use potential difference. Potential difference is work done with each charge, work done with each charge, work done with each charge. When people ask you about definition, you need to say it's work done with each charge.
You said define the potential difference is the same thing.
Yeah. Potential difference and voltage is the same. Okay, current. How to find? You got so many things. Can see 5.2. Can see 6. Can see 1.4. What is the current now? Okay, you try. Let's see how many of you can get correctly. Try. Tell me your answer. When you go there, you got see some omega student or not? 有看到吗？上面 report 的时候，对着看，不懂谁在那边啊？spy 嘛，你是 spy，这样跟你讲，对啊，是的 spy。
0.12.
0.125 not correct. Not 5， 差一点。Okay, this is EMF supply 吗？
You see the supply, not supply.
Actually there's a way to calculate. I think I need to teach you lah. This one is a supply. This one you use some of it here. Then the balance will go here. How many current are there? I current flow this way. So this 7 is the one supply. 1.4 will take up some here. Then this one is IR. R is 5.2. This one another I. Then I is 6. So what is I now? This one got formula 1. Formula 1 is sum of EMF equal to sum of IR. You learn this one in circuit. This one a bit just like that. That means you have to know this one stands for EMF. EMF is a source. Source will give the energy to other component. So source is 7, 1.5 go to the Z, then the rest of the energy go to these two. 0.5, right? 0.5. Okay, how to get the resistance for Z? Anyone can get or not? Okay. 接近来接近。接近是最后留下来的2.8。Right. You get 2.8. Today talk, I forgot to tell them. Do not afraid of challenges. You need to know how to take the hardship before you can enjoy the. Huh?
So many people from here, they say they will not take it.
They will not take. But surprisingly, this time quite a number. They say they are keen. After the talk, quite a number.
Just not the right inspiration.
No lah. I go there talk nonsense only.
Teacher, mindset, teacher.
Yeah. Somehow they can find the gold inside the nonsense. Okay, this is V equal IR. I think you know. Potential difference 1.4 ma. Current 0.5 ma. Then R we don't know. R is 1.4, 2.5, so 2.8. Okay, no? Efficiency. How do you calculate efficiency? Efficiency supply to the lamp. Lamp is here. What is the power used by lamp? What is the formula for power? IV or I square R. Right now. Okay, let you count and see. Percentage. Efficiency, you should know what is efficiency. Do you know what is efficiency? Useful output power over input power 100%. So useful, you have to use this input power. Where to get? Which one is the input power? Okay, how much is the percentage? Can anyone tell me? How much is it? The input power depends on this number multiplied by the current. Right? This is power is BI. Right? B you know already. I 2.5. Can you get a percentage? Yes, 43%. Okay, input. This one is useful one. You have to take the power of the lamp. So current of lamp we know is this number. Resistance 6. 2SF. The current is 0.5 square multiplied by resistance 6 over the input power 7 times 0.5, then multiplied by 100%. 100%. 100%. 43%, correct or not? 子英可以吗？子英？西北差吗？子英啊？Filament wire made from resistivity at operating temperature by this area and length is alpha. What is the formula for resistivity? R equal to what? Rho L over A. Can see the what is this? It's a A. A over what? L. Can you find this thing from here? Is what? A over L equal to what from here? Mathematics okay or not? How to change? Rho over R. Okay, so this is rho over R. Do you know the resistivity? What is the resistivity? Eh? Resistivity is the this one. Do you know the resistance of the filament wire? Do you have the value or not? What is the value? Is it going to be 6? Correct or not? So what is the value at the end of the day?
Resistivity is low.
Hmm. So how much is the value? You get 2 SF answer, 6.2 minus 8 meter. Okay or not? Area over length. Area is meter square. Length is m. So it's a unit meter. Yes, that's all. Team okay, team? Yeah. Yeah. How is it interesting or not?
Okay.
Okay. Basic. You're born in the year of dog, is it?
Yeah. So
Your dog. 2006. You also same. You're younger. You're born the year of pig. You know about it, right? 12 on zodiac sign. In the school, how many of you are same age to you?
think graphics engineering.
Engineering. The rest of them are dog.
1 year, 2 year.
Mm. Mm. Okay. Eh? Okay. Do you think you can do this? Tell me something positive.
Oh,
VIR. RVOI. Okay. Word over ampere, correct. Okay, at least you start to get things correctly.
if I learn potential difference over.
That's why you do a few times, you find that most of the time they're asking the same thing. Just apply the few formula only. ROL over A lah. Then about the definition, find the unit. If you're careful enough, you cannot get wrong one. They'll say, correct.
Formula sheet, they will every single formula. Like, what then for A level.
It's better you compile yourself. There's so many. Most of your senior normally I ask them to do it themselves. They normally have their booklet to write out everything one. Whenever they got a new definition, they will write it down and then the unit, everything. So they will refer.
So senior will
You can take picture. You can ask from, you can borrow from them if you want. You can take after you take ask them to lend you for a while, then you take picture, then you return to them. They also need to study. Okay. Not this one. How do we compare the resistance and total resistance of the connecting wire? You got wire, filament wire, connecting wire. Connecting wire, this is a wire from here until here. Filament wire only here. Resistivity is 1. How do you show this 1000? What is the formula for R? Rho L over A. How do you show that this is the equal to 1000? Can you show or not? A also equal to what? A is equal to what for wire? Formula for cross sectional area, if you know the diameter. Pi over 4 d square. Can you try to prove whether you can get 1000 or not? Show me. I want to see whether you can get the 1000, 1000 or not for your calculation. By using these two formulas, you see the same formula again. Why got different formula? Always the same area formula, always the same resistivity formula. Correct or not? You can do one. Don't say physics is tough. Physics where got tough? You misunderstood it already. It's not tough. It's just that you need to know a few things. Just always play around with the few concept. That's all. They didn't ask you more than that. It's always a vote, always a RO, L over A, always some simple calculation, show something. They're very nice to you. Actually, they're very nice to you. You have to learn to appreciate the beauty of the physics. Beautiful part of physics. You know, when I was teaching Omega 10 years, 15 years ago. Yeah. You know how many people score A for physics? A and A star. 75% one. A and A star for physics. Normally the Chemi Bio is lower one. Physics is the highest one. So among three subjects, actually the easiest subject is physics. But you don't believe in me. What can I say? Can we see? Nobody believe in this. 75%. 80%. Hey. Can get 1000 or not? Why cannot? What is the problem now? Filament. This is the first one, filament. Rho L over A. A, you have to use pi over 4 d square. Divided by another one. What is the other one? Rho, change to this number. L times 7. A, pi over 4, 14 d square. After that, this 4 go up. 4 rho L, pi d square. You tabulate this upside down. Pi over 4, 14 square d square over this number. So in calculator, can we see that? Can you see that this one cut? All the rho and L no more. So what is the number here? Can you see this is 14 square divided by 0.028 times 7. Is it equal to 1000? Yes or no? That means you're wrong already. Is it 1000 or not? Okay, so this is going to be 1000. Use the information in I, explain qualitatively why the power dissipated in filament of this is greater than the total power dissipated in the connecting wire. What can we see here? Resistance of wire is 1000 times greater than resistance of, oh, this is a filament. Resistance of filament is 1000 times greater. Wire. Power, explain why power dissipated in filament is greater than this. What is the formula for power? I square R or V square over R or IV. Which one shall we use here? You need to see the connection. What is the type of connection here? Series. What can we say about series circuit? What is same? Current. So current is constant. Do you see that? So if current is constant means you need to use this one. If current is constant, I is constant. So we have to apply I square R. So if I is constant, power depend on R. Correct or not? The greater the resistance, the greater the power. Okay or not? Just one more. What you write here? The greater the. So you have to mention about same current. Same current. Write down same current. The greater the resistance, the greater the power. Okay or not? Okay. Lamp, the voltage 12, power 6. Use the information I1 determine the total resistance of the wire. I1 is this one. Can we get the resistance of the filament from here? B and I are P and B. What is the relations between P and B? P equal to what? IV. Can we say use V square R? Because we need to find resistance. Right? Can you find the R? V square over P. What is V square over P? 12 square over 6 is what? What is 12 square over 6? 24. So this one 24. How much is the resistance of the resistance of the wire?
Like, zero, 45.
24 by 1000 because resistance of filament is 1000 times resistance of wire. So resistance of wire is this divided by 1000. What is 24 divided by 1000? Ai, 是啊。 没有办法，要努力了。没有选择下了啊，no choice 的，不要想放弃先，可以的，哪个 C 就好了，不用多了。啊，target 放低一点啊，先放低要求嘛，慢慢上，slowly go up。
这样子的。
没有啊，子怡啊，子怡没有啊，他讲他要继续啊，刘曼，刘曼，刘曼 already went already, I think today. Yeah, go already, go already. Yeah, it's not here. 忧愁不能低。哎呀，努力了，努力了，try your best 啊。Lack of confidence. Yeah, that's why I'm very surprised. She can get A1, actually she will stay. She stay. Give up too early. Give up too early. Because we take Mandarin, I don't know lah. Mandarin, not much market value one. Go and take. Oh yeah, don't know what. They don't want to listen. What can I say? Huh? 刘曼，刘曼也在咩？刘曼，刘曼有在。刘曼，中刘曼跟你一起啊？
来，
哦
老师你在这里。
，Hello，老师，我在这里。
嗨，知道。刚讲你早放弃，不是全部给你听到了啊啊？
他说你讲你捣蛋，给你听到啊。
是啦，说你去嘎教啊，只因上课啊。
那他叫我，
对了，
他突然间要跟你讲话，懂
是
的。
老师，我听到你的声音，非常的想你，所以我忍不住要跟你说话。
我呢？
来上 physics 了。
老师，我现在有点事儿，我先走了，自己好好说，
OK OK，你可以走了，拜拜。
拜拜。
Okay, let's continue. How to do it? Diameter decreases. Okay, decrease. Total L. Resistivity. Resistivity is a rho. So the rho doesn't change. Same. Explain, if any, occur to the resistance of filament of the lamp. Okay, so we come back to the formula. So you should know we need to apply R rho L over A. Diameter decreases. So what happened now? Diameter. Length of the wire remain the same. Just a while. This is about the connecting wire. Right now. This one. Diameter, that means this one become thinner. If this one become thinner, resistance of the connecting wire should increase. For connecting wire. Total resistance, everything is the same. Wire is the same, diameter decrease. State and explain any changes occur to resistance of the filament wire, the length. Okay. So we have to go back to the filament wire. Right now. Do you remember the graph of filament wire? Wire got graph one. If like that, what does it mean? Ohmic, right? Now. Then if for lamp, how does the graph look like? R is I over V over I. I over V. potential. The graph will look this way. Right? Yeah. Do you have the notes for wire? Wire, the filament. Like that, right? This one. Like that. Wire. So now you have to explain about the wire. How? Okay, so that means now like that for wire for this thing. So resistance decreases. Lamp. Because this one is wire first, you know. This one change. Resistance of wire change. Now we have to try to figure out what will happen to the lamp. Wire become less. What will happen to the lamp? If this one the resistance of wire decreases, that means current will increase. If current increase, what happens to the resistance of the lamp? Is the question. Wrong. Resistance of wire is not increasing. It's decreasing, is increasing, right? What happened to the current? Current should decrease. Current decreases. Okay, we have to think this way. For like that. Let's say this is the 6 ohm. This one increase. More potential drop. That means potential difference across the lamp will decrease. Why will decrease? 这个为什么变少掉？ The resistance increase, that means there will be some energy loss due to the wire. Because wire will take up some of the potential drop. So if this value decrease, current is the same. Maybe you can think this way. Let us think about it. Current. Three marks. Okay, so you have to think about wire, resistor wire, because of thinner. So we know already this is going to increase. When this thing increase, total resistance of the system increases, so current should decrease. Current decrease, that means less potential difference for lamp. So the resistance of wire also decrease. Does it make sense or not? Supply is still the same. I give you the same thing. Now wire become thinner. Wire become thinner. So there's a potential drop for wire. So potential difference for lamp will decrease. V is IR. So V decrease, R also decrease. Okay. How to write out? Okay. We explain the first part first, because the 3 marks, right? So first of all, talk about the diameter. Okay, this is for sure. The first one definitely correct one. Resistance of wire increases due to diameter of wire decreases. Decrease. Okay, first mark. So secondly, you have to talk about the current. What happened to current? Current increase or decrease? I mean, now we have more resistance. More resistance means what? Less current, right? Less current. So resistance of the current in the circuit decreases.
Any changes in resistance.
Yeah, that's why you have to deduce based on this. Current in the circuit decreases. Okay, what is the last one? Filament. Less current. Actually, you can explain by using the graph or no? Because if the I is higher, it means it's this point. If I is lower, then you move to this point. What can we say about the gradient? Do you know about how do you find the gradient? What does a gradient means to you for this one? V is IR, right? I is V over R. So 1 over R is a gradient. When you move from this point to this point, what can we say about the gradient? Increase or decrease? Which gradient is higher? We talk about these 2 points. This point is steeper or this one is steeper? Which point is steeper? Point 1 or point 2? Point 2 is steeper. Eh? If the gradient is steeper, what happened to resistance? Steeper, increase or decrease? Inversely proportional. Gradient increase, resistance decrease. Right? Actually, you should explain from here. You have to use the graph to explain. You understand? That means the current drop. So you have to refer to the this graph to see when the graph the current go to the lower value, what will happen to the gradient? Okay or not? How to write?
Gradient.
What gradient?
Gradient.
Yeah. Actually, this is just one the conclusion. Conclusion is what? Resistance of filament decreases. Strength of the filament decreases. Bare wire decreases. Why like that? Because from the graph. Then maybe you draw one graph here to show him. Actually, you know the answer. This, like this. Oh, I know, because this point go to this point. No, just show that actually it's from here. To show that you are very, very, very good in physics and you know a lot of things. Okay. 玻璃㗎，聽下先。Okay, let's see the next question. Wow, next question. How much do you understand about the next question? What is electric current? What is the definition for electric current? I is what? Potential difference. Why you always like to use this one? Q over T. Definition, only this one. The other one is Ohm's law. Ohm's law. We use Ohm's law to define resistance only. If you ask for resistance, then you can say it's a volt per ampere, something like that. Okay. Ratio of V over R. This one only apply for resistance. We're talking about current, always the second one. You know. Rate of flow or charge. Rate of flow or charge. How about this one? Is it very cold? 会冷吗？冷啊。Okay. A is what? In term state in term of this for total charge of the free electron. What is the formula for I? Na VQ. How about this? What is the definition for N? N stand for what? Number of charge carrier per unit volume. How do you find volume of this thing? AL, LA, AL. N is NLA, right? What is the formula for charge? Have you seen NE before? N is a number of charge, E is a charge of the electron. Number of charge is NAL, right? Times E. Get that? Show this. Use answer in one. What is the formula for I again? Do you have the formula for Q? And LAE. Is this one equal to this one? How to make it equal? Multiply T on both sides. L over T is V, correct? L over T is V, yeah? So NAVE. Okay, not? NAVE. Correct? Okay, now you got current, diameter, another diameter, length of the damage length, the wire in the circuit damage. Now rosak already, something damage. Density no change. No change. Cross-sectional area will reduce over this. So this is a new diameter. Okay. Current T, diameter of diameter D at S, diameter 0.69D at Y. Current in the wire 0.5 ampere. So drift velocity. So the formula is NA VQ. What can we say about the current? Which one constant? Is current constant or not? How do you know current constant? What kind of connection? How many flow are there? How many? It's only one line, right? It means same current. How about the N? Are they the same? N depends on what? Depends on type of the wire. How many type are there? One type. N. What else constant? Q's are constant. So, constant. What is the relationship between these two now? Directly or inversely? V is I over N AQI. Constant. Drift velocity depends on AI. A depends on what? A is equal to what? Inverse square law again, right? Can you base on inverse square law to get the answer? Drift velocity over 1 over t square. Okay, can you use this one to get the answer now? From here. Tell me the ratio of this question. How? How much? Okay, 子英跟到吗 ？OK 了。ratio OK。来，收单。the ratio V2 V1. That means this one upside down D2 D1 like that. Okay 了。So what is the diameter number 2? This one 1, this one 2 or this one 1, this one 2 or 2 1 2 1. Y is 2, S is 1 2 1. Oh, inverse is 1 2. Sorry. 1 2 2 1 become 1 2. 1 is the original. What is the diameter for original?
1
D, right? Second one is 0.69 D, right? D 0.690 square. Cancel. How much? 1/0.69 square. Yeah, 2.1. Can not? This also come up before, right? How many times you do this kind of thing? I think we have done at least 2 times. Yeah. Same one, 一样的 repeat only. Okay. What is this? R. What is this? L. So this is R over L. Damage wire. What is the R over L? Damage wire, the R and the L. What is the resistance? How can we find this thing? R equal to what? Rho L over AI. What is the L? R over L equal to what? Rho over AI. Fair enough. So rho over A, rho is it? Oh, is the is an O1. This one, the density, the resistivity is a constant. So this value is inversely proportional with A, right? Fair enough. Rho is constant. That means this value will change or inversely proportional with the diameter square. Because A is pi over 4 d square. That means R over L is 1 over d square. Fair enough. Okay, now inverse square law again. That means R over L for number 2 over R over L for number 1 is equal to inverse law. Which one is on the top? 1, 2, so become 2, 1 become 1, 2. Okay, based on this, write one more. Relationship with diameter, inverse law. Okay, now. Here 2, here 2, here 1, here 1. Okay, now. So what is the ratio of diameter 1 to diameter 2? What is the diameter 1? This one. So it's the same ratio, right? It's also D over 0.690, 2.1. So we are looking for the second one. R over L, number 2 is 2.1 times R over L, number 1. What is R over L, number 1? Originally, what is the ratio of R over L? So this value is this one, 1.7. So this is 1.7 times 10 to the power of -2. So how much is the ratio now? 2.1 times 1.7 to the power of -2. 3.6 times 10 to the power of -2 ohm meter. Fair enough. You have to know how to play with the mathematics or not. Actually, most of the time the physics is ratio only. Ratio calculation. Are you good in ratio calculation? Find relationship, divide, get the answer. Okay. How about the power? Lon? No lon. We got lon. Power formula, what is the power formula? I square R. Power. Power. Is it useful to us? I square R. What is the point of having this? If R over L equal to this, can we find the R or not? What is the length? Damage part. 3 millimeter. 3 times 10 to the power minus 3. 3.6 to the power of minus 2 times 3 to the power of minus 3. 1.08. Do you have the value of the current? Are we given the current for the question? 0.5. Can we use one here? Like this? Like that can get the answer, huh? What is the power again?
So
2.7 times 10 to the power of minus 5 watt. Do you get the idea now? Right or not? Idea? Most of the things can be found from the question one. You just need to know how to get the answer. Which one is which one? Try to link them up. Yeah. Diameter further decrease damage part. Explain qualitatively, it means no need to do calculation. The change to the power dissipated of the length. Diameter decrease. What happens when diameter decrease? It means become thinner, right? Thinner resistance will increase or decrease? Increase. So if this one increase, power depend on I square R, right? If R increase, what happen to the power? Power should also increase, right? Because I is a constant, P now depend on R. If R increase, power will increase. So more power loss, right now. Okay. So first one you talk about you can write more, this one write more. As diameter decreases, area decreases, area of wire decreases. So R increases. Power is I square R. I is the same. Power depend on R. So power increases. Okay, so this one just see the thing, further decrease. So here the tail decreases. Then the area of wire decreases again. Because area is pi over d square. This value decrease. If the d decrease, A will decrease. So R is rho L over A. diameter decrease, R should increase because it's inversely proportional. So when this one decrease, still the same current, so the power dissipated in the damaged wire will increase. Okay lah. Boleh. And then the next few part, too many only for today. I think we should do some revision anyway. No need to go too fast. Which topic, do you think that you want teacher to revise for you? Which topic or week one? You don't know which topic you're weak. Kinematics, dynamics, force, work done, pressure, deformation of solid weight, superposition. Wave. Okay lah. Wave and superposition. Maybe you do some revision for wave and superposition. Okay lah. Okay, if nothing else, that's all for today lah. Okay. See you. Bye-bye. Bye. Okay.